Simplifying multiplications and divisions with roots. In this video, we'll write distributive properties for exponents and roots over multiplication and division. We'll simplify examples with roots and with fractional exponents. Let's talk about PEMDAS again in terms of a distributive property. You know that multiplication and division distribute over the level below them, addition and subtraction. So we have things like 3 times a subtraction, x minus 2, is equal to 3 times x minus 3 times 2, 6. There's a similar property with exponents and roots, distributing over multiplication and division, so that if we have 3 times x in parentheses, and that's to the second power, the result is 3 to the second power times x to the second power, 9x squared. In general, we can say that a times b to the n power is a to the n times b to the n, and the nth root of a times b is the nth root of a times the nth root of b. And similarly, a over b to the n power is a to the n over b to the n, and the nth root of a over b is the nth root of a over the nth root of b. Now there's one caution I want to make here, which is that this exponent root level does not, that's a no, does not distribute over addition and subtraction. So a plus b to the n does not equal a to the n plus b to the n. We've gone down too many levels. The level distributes over the level just below it, not 2 levels down. To simplify the cube root of 125 divided by 27 times x to the 8th, I'm going to take advantage of this division and multiplication inside to separate each part into its own cube root. So I have the cube root of 125 and the cube root of 27 and the cube root of x to the 8th. The number parts simplify. The cube root of 125 is 5 and the cube root of 27 is 3. Now I'd like to find how many cubes I have in x8. So remember that when you multiply, you add the exponents. I have an x cubed and another x cubed that make x6. And to get x8, I would have to multiply by x squared. Now, I can simplify that by separating out each thing into its own cube root again. And so x cubes are in cube roots. Those are going to cancel out, and the x squared will be left. So this 3 cancels with the root, the exponent 3 cancels with the root, and these just turn into plain x's. So now I have 5/3 x squared cube root of x squared. To simplify this division, x to the 2/3 divided by y to the 4/3 all to the 6th power, I'm going to split that 6th power over the numerator and the denominator. They each have their own 6th power. So x to the 2/3 is to the 6th power and y to the 4/3 is to the 6th power. Well, when I raise a power to a power, I multiply the exponents. So in the numerator, I have 2/3 times 6, and in the denominator, 4/3 times 6. If I write the 6 over 1 to make multiplying the fractions more clear, then I can cancel that 3 in the denominator with the 6. Leaves a 1 in the denominator and a 2 in the numerator. And so the top simplifies to be 2 times 2 over 1, or 4. And the bottom, 4/3 times 6. 3 cancels with a 6, leaves a 1 in the denominator and a 2 in the numerator, and 4 times 2 is 8. So this complicated expression simplifies to something kind of straightforward. It's the same as x to the 4th, y to the 8th. We'd like to simplify the 4th root of x squared, y to the 8th. This problem gets much simpler if we rewrite the 4th root as an exponent. So a 4th root means a 1/4 power, and I have x squared, y 8th, those are multiplied to a 1/4 power. Since they're multiplied, I can separate the power over each factor. That's x squared to the 1/4 power times y 8 to the 1/4 power. When you raise a power to a power, you're going to multiply the exponents. So x is to the power 2 times 1/4. And y is to the power 8 times 1/4. Multiplying, I put a 1 under the 2. The 2 cancels with the 4 and leaves a 2 in the denominator. So now I have x to the 1 over 2, the 1/2 power. For y, the 8 has a 1 in the denominator. 8 cancels with 4 and leaves a 2 in the numerator. So that's y squared. Since my problem came to me as a root, I'm going to give it back as a root. X to the 1/2 power is the square root of x, and that's multiplied by y squared. When we're multiplying something by a root, we write the root last, so y squared times the square root of x.